Okay, so how to distinguish primary, secondary and tertiary amines? For this, we have several tests. Here I am going to discuss two important tests. Number one, Amines-Lecture test. Okay, what is Amines-Lecture reagent? For Amines-Lecture test, we are using a reagent. It is called Amines-Lecture reagent. Amines-Lecture reagent is nothing but benzene sulfonyl chloride. Let me write here. Amines-Lecture reagent, nothing but benzene sulfonyl chloride. This is called Amines-Lecture reagent, and the formula of Amines-Lecture reagent is, we have benzene ring with a sulfonyl group is attached and a chlorine. This is what we call as benzene sulfonyl chloride, and this is the reagent that we are using for Amines-Lecture test to distinguish primary, secondary and tertiary amines. Okay, now right, how to distinguish using this? Very simple. You take primary amine, add Amines-Lecture reagent. Okay, some chemical reaction takes place, you will get some product. This product is soluble in alkali. If you take aqueous sodium hydroxide or aqueous potassium hydroxide, in that solution the product is soluble, so you will get a clear solution. Primary amine reacts with the Amines-Lecture reagent, gives you a clear solution, okay, in alkali. This is what we call as so this is the characteristic reaction with the primary amine. I repeat, primary amine reacts with the Amines-Lecture reagent, it forms a product. That product is soluble in alkali, right? So the final solution looks like water. It's clear solution. Okay, this is the characteristic behavior of primary amine in Amines-Lecture reagent, with Amines-Lecture reagent. Then what about secondary amine? With the secondary amine, if you add Amines-Lecture reagent, chemical reaction takes place, you will get a product, but the product is insoluble in alkali. Okay, this product is insoluble in alkali, so the solution is not clear. Okay, it appears like a heterogeneous solution, right? Secondary amine reacts with Amines-Lecture reagent, it forms a product. The product is insoluble in alkali, and the solution appear like an heterogeneous solution, right? So this gives you clear homogeneous solution, this gives you an heterogeneous solution. You can easily identify. If you go to tertiary amine with Amines-Lecture reagent, tertiary amines do not undergo any reaction. No reaction with the tertiary amine. Okay, so based on these, you can easily distinguish primary, secondary and tertiary amines. We call this test as Amines-Lecture test. Okay, yeah. What is the chemical reaction behind? What's the product formed with the primary amine, with the secondary amine, with the tertiary amine? Tertiary amine, no reaction. Okay, what's the product formed with the primary and secondary? Why they are soluble in alkali? We'll discuss that. Now, so let me start with the primary amine first. Here I took a primary amine, RNH2. To this, if I add benzene sulfonyl chloride, listen student, nitrogen has lone pair. Using that lone pair, it attacks the sulfur. Therefore, what will happen? Pi bond shifted to oxygen. It will become O minus. That O minus once again comes back and form a pi bond, so that this chlorine will come out. I repeat, nitrogen attacks the sulfur atom. The pi bond will shift to oxygen. That O you will get O minus. That O minus again comes back. Once again it forms pi bond. Then when it comes back, this chlorine comes out with the bond pair as Cl minus. And here what happens, since nitrogen donates the lone pair, nitrogen gets positive charge. To neutralize that positive charge, one hydrogen comes out as H plus. So here one H plus coming out, here one Cl minus coming out, H plus and Cl minus combine and form HCl. Now you will get a new bond between nitrogen and the sulfur. So you will get this product. Okay, so this is something look like sulfonamide. Okay, this is called sulfonamide. So it is nothing but benzene or substituted benzene sulfonamide is formed, right? And listen student, here this is very important. This hydrogen is acidic because it is directly connected to electronegative atom, and the electronegative atom, it is connected to an electron withdrawing group, so this is more acidic. Okay, since this compound has acidic hydrogen, if you add aqueous KOH or NaOH, okay, this OH minus will remove this H plus and form an anion. See, the OH minus remove this H plus and form an anion, and the K plus, right, it acts as a counter ion, so you will get a salt. You will get a salt and having a positive ion and the anion, right? And this salt, you know very well, most of these salts are soluble in water, so this salt dissolves in water, you will get a clear solution. So this is the reaction takes place with the primary amine. Okay, so primary amine, with this if you add benzene sulfonyl chloride and HCl is eliminated, you will get a substituted benzene sulfonamide. This R group is attached to nitrogen, it is called substituted amide, and we have benzene here, so it is called substituted benzene sulfonamide. And in sulfonamide we have a nitrogen here. This hydrogen is acidic. Because of the presence of acidic hydrogen, this compound is soluble in water. Why it is soluble? Because soluble in alkali. Why? If you add alkali, OH minus, remove this H, hydrogen as H plus. So, and water molecule is eliminated, and you will get a negative charge on nitrogen. You will get an anion, and the counter ion is K plus, so you will get a salt. We all know that most of these salts are soluble in water. Since we are taking aqueous KOH, so we have water here, so in that water it dissolves, you will get a clear solution. So the point here is primary amine reacts with Innsbruck reagent, you will get a product. That product is soluble in alkali. Okay, yeah. Then second point, what about with the secondary amine? Here I took a secondary amine, okay, 2R group directly connected to nitrogen, and the nitrogen has only one hydrogen. To this I am adding benzene sulfonyl chloride, Innsbruck reagent. What will happen? The lone pair on nitrogen, it attacks the sulfur, as I said before. So pi bond will shift to oxygen first. You will get negative charge. That negative charge once again comes back. You will get double bond again. When it comes back, this chlorine comes out as Cl minus. And here, since the nitrogen donate the lone pair, the nitrogen get positive charge. To neutralize that positive charge, this hydrogen comes out as H plus. So you will get H plus here. You will get Cl minus here. These two combine and form HCl. So HCl is eliminated. Now what's the product we'll get? You will get a bond between nitrogen and the sulfur. So you will get this product. Now students observe this. This is also substituted sulfonamide. Okay, di-substituted, right? Actually 2R group are there. Di-substituted benzene sulfonamide is formed. But now here there is no hydrogen, no acidic hydrogen present. No acidic hydrogen here. Therefore, if I add aqueous KOH, since there is no acidic hydrogen, this compound is an organic compound. You know very well, most organic compounds, okay, are most of the organic compounds are insoluble in water. Okay, since it is insoluble, right, the solution appear like an heterogeneous solution. Okay, you'll get an heterogeneous solution, or I can say the product is insoluble. Okay, so you can easily identify the secondary amine based on this test. Take secondary amine, add benzene sulfonate chloride, HCl is eliminated in the first step, you will get a product. What's the product? Di-substituted benzene sulfonamide is formed, sulfonamide. And there is no acidic hydrogen, so it does not form any salt with aqueous KOH. So this product is insoluble in water, so it will appear like a heterogeneous solution. With the primary amine, you will get clear solution, homogeneous. With the secondary amine, reaction takes place, but the product is insoluble in aqueous KOH, so you will get heterogeneous like solution. What about with the tertiary amine? In tertiary amine, students observe carefully, nitrogen has lone pair, but there is no hydrogen attached here. Okay, if nitrogen donates, suppose if nitrogen donates the lone pair, nitrogen become positive to neutralize the positive charge. There is no hydrogen available here. Therefore, tertiary amines do not undergo this reaction, no reaction. Okay, with Innsbruck reagent, tertiary amines, they do not react. Simple. Okay, so based on this, you can easily distinguish primary, secondary and tertiary amines. Okay, students, is this clear? Any doubt here? Any doubt? Hello, students?
No doubt, sir.
Okay, so this is what we call as Innsbruck test. Now, let me discuss another important test to distinguish primary, secondary and tertiary amine. It is nothing but test with nitrous acid. This is a very important test. Often we expect this question in competitive examination as well as in the board examinations. Nitrous acid, HNO2. You know, student, you know very well, nitric acid, HNO3, it is quite stable. You can store it in lab. Storage stability, I can say like that. Storage stability is high. You can store it in lab. Okay, you might have seen nitric acid in your laboratory. But HNO2, nitrous acid, it is unstable. Or I can say less stable. Less stable, so you cannot store. One cannot store nitrous acid in lab. Cannot store in lab. Because the stability is very, very less, it will decompose readily. Therefore, whenever nitrous acid is required in a reaction, you have to produce nitrous acid in situ of the reaction. Okay, within the solution you have to produce this. Okay, so how to produce nitrous acid? Very simple, student. To produce nitrous acid, listen, just to take aqueous sodium nitrite. Sodium nitrite is a salt. Dissolve the salt in water and take hydrochloric acid. Aqueous hydrochloric acid. Okay, if we mix these two, what will happen? Na plus NO2 minus we have. Here we have H plus and Cl minus. Na plus combined with the Cl minus form NaCl. NaCl aqueous. H plus combined with the NO2 minus form HNO2. You will get nitrous acid. Okay, this compound is called HNO2, is called nitrous acid. Stability is less, so you cannot store it in lab. You have to prepare this only within the reaction medium. Okay, and what is the structure of nitrous acid, student? Observe carefully. OH N double bond O. Okay, this is the structure of nitrous acid. HO N double bond O. Okay, remember this. Now, using nitrous acid, you can distinguish primary, secondary and tertiary amines. How? Listen, first I'll take a primary amine. How to distinguish primary, secondary and tertiary amines using nitrous acid. It is actually very simple, student. Listen, in primary amine, first I'll take aliphatic primary amine. Aliphatic primary amines. With aliphatic primary amines, if we add nitrous acid I'm not adding nitrous acid. You have to prepare within the medium. How to prepare nitrous acid? Very simple. Mix. How to prepare this? Mix sodium nitrite with HCl. If you mix these two, you will get nitrous acid. That nitrous acid reacts with the aliphatic primary amines and form a primary alcohol, the corresponding alcohol. You will get an alcohol. And this is very important, student. Nitrogen bubbles will come out. Nitrogen gas is eliminated. So you can see effervescence of nitrogen. Student, observe carefully. Aliphatic primary amines reacts with the nitrous acid, produce effervescence. The effervescence is due to evolution of nitrogen gas. With aniline, I'll take this one. This is very important. Aniline. Aniline is also primary amine, student. You know very well. See the structure of aniline. Aniline is also primary amine. See, nitrogen has 2 hydrogen atoms. It's a primary amine. But with aniline, if you add nitrous acid, HNO2, you will get a stable diazo product. Diazonium product. Diazonium. Let me write like that. You will get a stable diazonium product. Okay, and in this reaction, you will never get any nitrogen gas evolution. Nitrogen gas evolution never happens here. Okay, though it is a primary amine. So it's very important, student. Keep this in mind. Aliphatic primary amines reacts with the nitrous acid, form alcohol and produce bubbles of nitrogen. Whereas aniline reacts with the nitrous acid, forms stable diazonium product. And in this case, no nitrogen gas is evolved. Okay. Now, what is the actual reaction? What happens here? Let me write the reaction in the next page. What happens with the aliphatic primary amine? Listen, student. I'll take some primary amines, say for example CH3, CH2, NH2. Ethanamine. I took ethanamine. It's an aliphatic primary amine. Okay, it's a 1 degree amine. Now what I'm going to do? I'm going to mix sodium nitrite and HCl. If I put sodium nitrate and HCl, you'll get HNO2. Let me write HNO2 like this. HONO. This is the structure actually, right? If you mix these two, you will get this product. This is produced in the solution medium, a reaction medium. Now this will react with this compound. Right? How it will react? Listen, student. And H2O is eliminated actually. So you get this product CH3, CH2. Okay. Listen, student. Very simple. This nitrogen, just for understanding purpose, I am telling you this. Nitrogen has 2 hydrogen here. To eliminate water, what is water formula? H2O. To eliminate water, you require 2 hydrogen and 1 oxygen. Okay. To eliminate 1 water, you need 2 hydrogen and 1 oxygen. Now nitrogen has 2 hydrogen. And here, this side we have 1 oxygen. So H2O is eliminated by taking oxygen from this side. Now this N double bond group get attached with this nitrogen. So in this nitrogen, remove 2 hydrogen, put a double bond and N connected with this OH. It is called a diazo product. It is called diazo product, but aliphatic diazo, it is an aliphatic group. Aliphatic diazo group, okay, is highly unstable. This compound is highly unstable. Then what will happen? It will immediately decompose, right? So that this N2 comes out as nitrogen gas and the OH attached with the CH2 group. CH3, CH2, OH plus nitrogen gas is released. This is what happens with aliphatic primary amines. Okay, aliphatic primary amine reacts with the nitrous acid, form alcohol. Students, keep this in mind. It form alcohol and nitrogen gas is released. What will happen if I carry out the reaction with the aniline? Aniline also primary amine. This is also primary amine. Okay, but here if I add nitrous acid, HNO2, you know very well how to produce nitrous acid by mixing NaNO2 HCl. Now what will happen, students, observe carefully. Diazotization takes place. This NH2 group get diazotized, okay, between the temperature of 0 to 5 degrees Celsius. Between 0 to 5 degrees Celsius under cold condition, if you mix these two compounds, okay, you will get a diazotized product. What is the diazotized product? Is N2 plus, okay, Cl minus. Because we prepare this HNO2 by mixing sodium nitrite and HCl. So here we have chloride. That chloride will act as a counter ion here. What is this compound called? This compound is called as benzene, and we have diazo group, diazonium chloride, and this is a salt actually. Benzene diazonium chloride is a salt and it is stable. It's a stable salt. Okay, so with aliphatic primary amine, the diazo product is not stable, whereas with aromatic or aniline, with aniline the diazotized product is stable, student. Okay, what is the structure of benzene diazonium chloride? Let me write here. Benzene diazonium, okay, N triple bond N plus. Okay, you can write like this, or you can write with the double bond also. Okay, in any manner you can write. So here this is the cation and anion is attached here. It's a counter ion. Okay, this is the structure of benzene diazonium chloride. Okay, and this is stable product. Keep this in mind. It's a stable product. We are going to discuss about the chemistry of benzene diazonium chloride as we go along. Okay, so in general, aliphatic primary amine with nitrous acid form alcohol and you will get effervescence. The effervescence is due to evolution of nitrogen gas. But there are exceptions. Aniline, right? Although it is a primary amine, it reacts with nitrous acid. It does not produce any nitrogen gas, no nitrogen gas. It forms a stable salt called benzene diazonium chloride. Okay, students, is this clear? Any doubt? Hello, student?
No, sir.
Yeah, this is one of the method to distinguish aliphatic primary amine and aniline. Student, sometimes they will ask, how will you distinguish aliphatic primary amine and aniline? Aliphatic primary amine with nitrous acid produce effervescence of nitrogen gas, whereas aromatic, that is aniline, reacts with nitrous acid, form a stable salt called benzene diazonium chloride. There is no nitrogen gas evolved. Okay, now what happened with the secondary amine? What will happen if reaction takes place with the secondary amine, with the 2-degree amines? Right. Now let me take a 2-degree amine, CH3, CH2, some 2-degree amine. I took aliphatic 2-degree amine, secondary amine. Okay. Now to this, if I add nitrous acid, okay, I'll just put HO, NO, and you know very well how to get this by mixing sodium nitrite and HCl. Okay, if I mix these two, I'll get this. Now how it will react? Listen, student. Now this nitrogen has only one hydrogen. To eliminate water H2O, right? We have one hydrogen here. So what are the remaining things required? One more hydrogen, one oxygen. So you require a HO group. Therefore reaction happens, okay, between these two. So these two combine and form water molecule. Okay, just for understanding purpose I am saying like this. Okay, water molecule is eliminated, and this group called nitroso group, it is get attached with the nitrogen. Students, observe carefully. CH3CH2 N CH3. Now to this nitroso group get attached. This group is called nitroso group. You'll get a nitroso group. And if you observe carefully, student, this compound, okay, it is insoluble in water and appear like an yellow oil liquid. It's an yellow oil. So your solution become turbid. Take secondary amine. Okay, see, both are aqueous solution, aqueous NaNO2, aqueous HCl. If I mix these two, I will get clear solution. In that solution, you add the given secondary amine. If you add a secondary amine, you will get an yellow oily liquid or yellow oily turbid like liquid. It is due to the formation of this compound. It is called nitrogen as NO group. So N-nitroso. Nitroso group is attached with the nitrogen. So it is called N-nitroso. And we have two alkyl group. In this, this is larger alkyl. Sorry. So this is the parent chain. So the name is N-methyl ethanamine. Ethanamine is the name. So with the secondary amine, nitrous acid forms N-nitroso amine. N-nitroso amine is an yellow oily liquid. Okay, so with the aqueous solution, it appears like a turbid solution. Okay, yellow oily, that yellow oil dispersed throughout the solution and look like a turbid solution. Okay, so this is what happened with the secondary amine. Here, listen, student, no nitrogen gas is evolved. Okay, secondary amine react with the nitrous acid, no doubt, it react and form N-nitroso amine. N-nitroso amines, right? Almost all yellow nitroso amines form yellow oily liquid. Okay, you'll get yellow oily liquid. You can easily through naked eye you can see the yellow oily turbid solution, so you can easily identify. And one more point, there is no effervescence no effervescence produced. Okay, because no nitrogen gas is eliminated. Right? Okay, what happens with the tertiary amine? What will happen with the tertiary amine? Tertiary amine, okay, let me take a tertiary amine like CH3CH2 CH3CH2. I'll take a triethylamine like this. Triethylamine. Now nitrogen has a lone pair, no doubt. To this, if we add NaNO2 and HCl, you'll get nitrous acid. You'll get nitrous acid. Now listen, student, observe this carefully. Now, see, this is a base. There is no hydrogen available here. See, in primary amine and secondary amine, the nitrogen atom has at least one hydrogen. In tertiary amine, there is no hydrogen available here. So, it does not react like this, like primary amine or secondary amine. It will behave like, see, this is a base, this is an acid. Okay, you'll get just a salt. You'll get a salt. Okay, right? So, take note. So, what is the salt you'll get? CH3, CH2, thrice N. Okay, it transfers one hydrogen, so NH plus, and you'll get NO2 minus. You'll get a salt like this. Okay, you'll get, see, this salt is soluble in water. Okay, so your solution become clear. The salt is soluble, so your solution become clear like primary amine, but there is no evolution of nitrogen gas. See, student, you have to distinguish primary, secondary, tertiary amine with the nitrous acid. Okay, I have told you, if I add nitrous acid with the primary amine, almost all aliphatic primary amine, okay, produce an effervescence with the nitrous acid. The effervescence is due to evolution of nitrogen gas, and there is an exception, that is aniline. Aniline does not produce any effervescence. Okay, because aniline reaction is entirely different. Whereas if I take a secondary amine with nitrous acid, it forms N-nitrosoamine. N-nitrosoamines are yellow oily liquids, okay, which is formed in aqueous solution, so the solution become turbid. What about tertiary amines? Tertiary amines, since there is no hydrogen available with the nitrogen atom, it does not react with nitrous acid like aniline, like primary amine and secondary amine. Okay, how it will react? It is simply an acid base reaction. So, because amine is a base, okay, nitrous acid is an acid, so acid and base reacts and form a salt. And you know very well, most of the salts are soluble in water, so it dissolves in water. You will get clear solution like primary amine, but you will never get any effervescence here. Okay, so based on this, you can easily distinguish primary, secondary, and tertiary amines. Okay, students, is this clear? Any doubt? Hello, students? Hello? Hello, students, am I audible?
Yes, sir. Yes, sir.
Right. Right. So you can distinguish primary, secondary, tertiary amines using this technique. Right. Now, we have discussed some important reactions of amines. Now, I am going to focus on reactions of aniline. Reactions of aniline. This compound is called aniline. Right? The first important reaction is diazotization. Listen, student. Aniline is a liquid. By nature, aniline is a liquid. Right? In pure form, if you prepare aniline in pure form it is colorless. I have told you this point already. In pure form it is colorless, but when you start to open the bottle, okay, aerial oxidation, right? The atmospheric air contain oxygen. That oxygen slowly oxidizes this aniline. So due to aerial oxidation, okay, due to aerial oxidation, the solution become a slight brown, reddish brown. Okay, slowly turns reddish brown. It is because the compound is get oxidized. Okay. Now, listen, students, this is very important reaction. Synthesis and all we have discussed already. So I am going to discuss only the chemical properties. First reaction is diazotization. This is very important for the competitive examination as well as for the board examination. Diazotization. Listen, student. You take aniline. Aniline is a liquid, I have told you. You take this liquid in a separate test tube. Then you prepare sodium nitrate, aqueous sodium nitrate and aqueous HCl. Okay. Then mix these two under ice cold condition. So what I am trying to say, take aniline, to this add NaNO2 plus HCl, aqueous solution. You take aqueous solution of NaNO2 and HCl, mix it with aniline under cold condition between the temperature 0 to 5 degrees Celsius. Under ice cold condition you have to carry out the reaction. And what we'll get? We get this compound called benzene diazonium chloride, N2 plus Cl minus. We get this product. Okay, you can also write like this: benzene N triple bond N, and put positive charge on this nitrogen and Cl minus. You can also write like this: benzene diazonium chloride. Okay, this reaction is called diazotization reaction. Okay, conversion of aniline into benzene diazonium chloride is what we call as diazotization. Diazotization takes place at a very low temperature, it is between 0 to 5 degrees Celsius. Okay, now second reaction, this is what we call as diazotization. Number 2, aniline, it has benzene ring and NH2 group act as a donating group. Okay, let me write here. So it shows aromatic electrophilic substitution reactions. Aromatic electrophilic substitution reactions. Since there is an aromatic ring available, aniline undergoes electrophilic substitution reactions. Okay, it is called aromatic electrophilic substitution reaction. Okay, listen students, this is very important. In aniline, NH2 group is directly connected to nitrogen and the nitrogen has a lone pair. You know very well, whenever directly attached atom to the benzene ring, it may be any atom, if it has a lone pair, at least one lone pair, then due to resonance, it can donate the electron density or the lone pair to the ring. Okay, it will donate the electron density towards the ring. Therefore, what will happen? Electron density on the ring increases. Electron density on the ring increases because the group is electron donating group. Okay, whenever the directly attached atom has a lone pair, we call the group as electron donating group. Okay, electron donating group donates the lone pair to the benzene ring. So electron density on the ring will increase. Will electron density increases equally on all carbon? No. Listen student, here we have 2 ortho carbon, we have 2 meta carbon, and we have 1 para carbon. Right? Usually students, or in almost all cases, electron donating group, so NH2 group is electron donating. Electron donating group increases the electron density at the ortho carbon and at the para carbon. So electron density on ortho and para, okay, is much greater compared to electron density on meta position in aniline. Why? Because NH2 group is an electron donating group. Due to this, electron density on ortho and para position is high compared to meta. And you know very well, electrophilic substitution reaction happens where or occurs at the site where electron density is high. Therefore, electrophilic substitution reaction, what does this implies? It implies that electrophilic substitution reaction occurs right at ortho and para position, which is the preferred position. Why? Because ortho and para has high electron density. So electrophilic substitution occurs preferably at ortho or para positions. This is very important student. Keep this in mind. Where electrophilic substitution takes place? At ortho and para position of aniline. Why? Because NH2 group of aniline is an electron donating group. Okay, now let me show a few examples so that you can easily understand how this happens. Let me take a few examples. One second, student. There are plenty of examples available, but only few are discussed in the textbook, so I'm going to discuss only those. Okay, actually there are many available. Right. First, let me take we have a sulfonation reaction, we have nitration reaction, right, etc., etc. let me take one or two examples and explain how the electrophilic substitution reaction takes place on benzene ring. Okay, yeah, the first and important reaction here is halogenation reaction, specifically bromination. Number one, I'll take bromination. Bromination. Student, this is a very important reaction for aniline. Why this is very important? It is a test for detecting aniline. Okay, it's a general test, not a specific test. It's one of the tests available. Alright, so what's the test actually? What's the reaction? The reaction is simple, student. You take aniline. I have told you aniline is a liquid. And you take bromine in water. Students, observe carefully. Bromine in water. Okay, so take aqueous bromine in a test tube, then add few drops of aniline in that. What will happen? Bromination takes place at the ortho and para position. Listen, student, water is a polar solvent. In presence of polar solvent, substitution occurs at ortho as well as para. Okay, so the product what we get as, see here we have NH2 group, right, and we have benzene ring. Now let me put a bromine here at ortho positions, 2 bromine and 1 bromine at the para position. Tri substitution occurs right in the presence of water. Right, you'll get, what is this compound called? It's called 2, this is position number 1, this is 2, 3, 4, 5, 6. So we get 2, 4, 6 tribromo, 2, 4, 6 tribromo aniline. 2, 4, 6 tribromo anilines. Listen, student. After attaching 3 bromine atom, this molecule become very heavy. Molecular weight becomes so high. So this compound, okay, starts to precipitate. Because molecular weight is heavy. So in solution phase, okay, it cannot exist in solution phase. It will come down. It will form a precipitate. So you will get a white precipitate actually. So you will get a precipitate. Plus HBr is removed. Okay, so here actually 3 bromine molecule reacts. Okay, so that 3 bromine atoms are attached with the benzene ring, and 3 bromine atom comes out as HBr. Right? Listen, student, why this reaction is important? The reason is, listen, bromine water. Listen, students, suppose you are in a test tube. If you take bromine water, you take bromine in water. It appear like reddish brown. Okay, reddish brown bromine water. To this, suppose I take some compound A. If I add this compound A, if the solution, see, solution is reddish brown, if the color disappears, okay, and no precipitate, color disappear and no precipitate, we call the compound A as unsaturated compound. We call the compound A as an unsaturated compound. Okay, it's a test for unsaturated compound. You take bromine in water, okay, it is actually a reddish brown color. To this, you take a given compound, add the given compound in the solution. If the color of the bromine water disappears and there is no precipitate formed, we call that compound A as unsaturated compound simply. Sometime instead of the compound A, if I add aniline or phenol, students observe carefully, this reaction also happened with the phenol. If I add aniline or phenol in that instead of A, what will happen? The color disappears. Color disappears and you will get a white precipitate. You will get precipitate. Okay, here this the product, so you'll get the color disappears and you'll get white precipitate. It indicates that the compound is not unsaturated, it is saturated. It is saturated only. Just because bromine water color disappears, you should not say that it is a unsaturated compound, because along with we are getting a precipitate. Okay, so this is actually a saturated compound. Keep this in mind. It's a test for aniline and phenol. This reaction is shown by aniline and phenol. Okay, right. Take the students. A very important one. Substitution occurs only at ortho and para position. Why? Because electron density at ortho and para is high compared to meta. So reaction happens only at ortho and para positions. But since we have taken polar solvent, in polar solvent maximum substitution takes place. So substitution occurs at ortho, both ortho as well as para. Yeah, substitution occurs at both ortho and para positions, right? And this is a very important one, because aniline and phenol, they are saturated compound. They are not unsaturated. Okay, because if you add bromine water to aniline or phenol, listen, if you add any compound to bromine water, if color disappear, if you don't get any precipitate, yes, it is unsaturated. But with aniline and phenol, what happens here? Color disappears, but you will get a white precipitate. So if white precipitate appears, it means the compound is not unsaturated compound. It is actually saturated compound, but easily brominated. Easily brominated compounds. You can easily brominate. Okay, so that is the meaning for this reaction. Okay, yeah. Students, is this clear? Any doubt? Hello, students, is this clear?
Yes, sir.
Right. Okay, students, I stop here. We'll discuss this in the next class.
Thank you, sir.
Thank you.
Thank you.
Thank you. Thank you.
Thank you, sir.
Thank you. You can leave now.